Hello, how are you? Good morning, good afternoon, good evening. Let's get our cup of coffee and start. We continue with yet another comprehensive exercise, and we can see that we have in this case logarithm of x between x all multiplied by dx. In order not to lose the habit, let's copy again the part of the complete integral to be able to make and not ruin the one we have initial. And it would look just like it. Very good on us. So far, we are going to make a recap of everything we have done in the episodes. We have seen chain rule. We have seen the direct formula application part. In this case, the previous episode. If you haven't seen it, go check it out. Logarithm also, we have seen the part as rules for taking out all constants within the integration or numbers. If it is possible to remove it, we must take one. Or always a u is something, a term that is within the integral, and it is necessary to make a du. That this du is the derivative of miu, and that du is a differential. That differential must be complete within the integral. Try to complete it, and if we cannot complete it, well, we have already proceeded with another method. And so far, the universal rule of this channel is to try to solve it with the simplest method and efficient possible to save us as much time as possible. Very well, in this case, we have logarithm of x between dx as the main rule. We know that we need a u and a du, that is by law, both to apply direct formula and to apply the rule, part of the chain. Okay, perfect, very good. In the previous case, this is going to be like a note, put an asterisk here. Let's talk to you a little bit. Something important, what we saw in the exercise of the previous episode, we observed that we had the integral a du at the top and a u at the bottom. In order to integrate, very well, this was equal to what a logarithm of u more c. Very well, we had a u at the bottom and the differential at the top. We can observe the part that we have a division. We have this division here and they have logarithm. They say, well, we can try to use this formula, see if it works. U and du, we see the bottom. What is at the bottom? We have an x. Then to use this part is the same as the previous episode. We should take like x in this case. The du would equal dx, agree? And dx is totally different to what we have at the top, as it is different at the top, we would need x that we do have from x, but we will have enough logarithm of x. In this case, it is not possible to perform it by the same method, the same formula. Okay, let's go back. Okay, now clean up. The slate has already clarified the previous episode that it is not possible to apply it the same way, but what we can reapply is that there is a direct formula in your form that you can use in order to solve this exercise very well. As I always tell you in all episodes, it is necessary to take one as and from there we are going to get a very good u. What do you think if we take as u the part of the numerator? This is going to be our, okay, very well, our u would be the logarithm of x perfect. Now we have to bring out our du. The du is derived from the logarithm of x, which that's the differential, and that differential, because we should have it within the same comprehensive agreement. Perfect. What is the derivative of the logarithm of x? Check your form and let me know. The derivative of the logarithm of x is 1 over x by dx. Okay, perfect. Let's take a good look. Practically the equation we have to integrate, if this we have to integrate, is the logarithm of x between dx by dx. How we could break it down? Let's copy it again here at the bottom to rearrange it rather, so that you can observe if we have complete differential, because this is not complicated. We simply need to observe in a strict manner and develop the ability that develop the ability to observe certain details, patterns, to know how we are going to solve the exercise. Perfect, that is done practicing and nothing else. Okay, then logarithm of x is in the numerator. Agree, very well, we would have logarithm of x in the numerator. Well, that it is multiplying to 1 over x and is multiplying to the dx. Agree. Okay, perfect. This we have here is exactly the same. That what we have up here is the same. We simply accommodate the factors that we accommodate the terms. Yes, we respect that the logarithm dx is in the numerator and we leave it the upper part. Well, the x is on the denominator at the bottom, and we respect and we leave it at the bottom, which is equal to 1 between x and dx. We knew it is multiplying everything. Then we place the dx in there very well. Now observing, we have our u. What do we have here? We take as this is our u that we have already placed it at the top, and as a differential we need complete one between x dx and c here. What we have 1 between x dx. This is ours. Du, and it is complete. Tell me all? Yes, it is complete then. And now that we are sure, we have the u and we have the complete du, we have the differential complete. What is this that I just put here? Then we proceed to use what the rule of the chain. The rule of the chain tells us that if we have a u, we must have the full du. Okay, perfect. In this case, with what the chain rule for those persons, that they have already forgotten what the chain rule is. Tells us that we have 1 or 1 and we add 1. And let's divide it by n plus 1. This is the rule of the chain. Is chain rule. Asks us to those requirements that I have just mentioned. And by completing them, then we proceed to simply replace. Okay, perfect. Let's put here the solution that fits at the bottom of what we were being asked for at the beginning, and replacing how it would look like to us, which was our u. Our u was logarithm of x. Very well. Logarithm of x to what is elevated to the one that has that one but is not placed, because that one is not too much to place the numbers. One agree because they are already there. We know that they are kind of invisible, but they are very good there. Plus 1 tells us the formula between n plus 1, 1 plus 1. I am not explaining where we got the n, because in other episodes we had already talked about it very well, and this is how much we would be left with. Logarithm of x squared between 2. All good so far? Okay, perfect. Then we are done. We are not done. Remember what we are missing, what is important. Message to post an integral result. We need to add the part of the integration constant. Then the correct result would be logarithm of x. Everything is squared and divided between 2 more c. This would be our result of what we were asked to do at the beginning. Okay, the logarithm integral of x over x multiplied by dx is equal to the logarithm of x squared between 2 plus c. Okay, all agree. Perfect. I hope if they had doubts, something that has made me a little clearer, has been well explained. Then if you have any comments, any questions, please post them in the comments below. At the bottom of the video, more information is also available. If you have any questions, want to solve an exercise, do you have an exam coming up, please contact me with the information that comes at the bottom of the video. And without further ado, take good care of yourselves, have some coffee, see you next time. Thank you.